All right, can you hear me? Welcome back. So the food pantry person was supposed to be here to talk about assistance that if you need it. I'm not sure where they are, so we'll see. Maybe they'll show up next week or things like that. But we can just get started with our lecture as it is if they're not going to be here. Okay, so last week, a little bit of a turbulence in our course, huh? Some of you showed up to classes with some TA and not without TAs, things like that. So I guess that's how college is supposed to be? Is that it? No, it is our bad. So of course, anything that we are responsible for, we're not going to make you have to pay for it, right? So even though the lab is due today, you know that there's a resubmission period, so it will not be counted as late anyways for you guys to finish through lab 2, which is actually not that much work to do, so you can actually do it in the beginning of this week's lab. And if everything goes well, cross all our fingers, all the TAs should show up to all the sessions and you should have it, right? This is what they mean by life has challenges unexpectedly, I guess. You get emails at 8 a.m. or something like that. My TA didn't show up. Really? Oops. It's like, I didn't know. So any questions or concerns about that? Okay. So just remember that our system is set up so that you guys can, have no issues with how the course is and learning all the things. And one of the biggest reasons why we have Lab 2 the way it is one, there's a very technical skills that we try to teach you in it, which is how to download files from CAT courses into your own folders, and then that you can also load them into your Eclipse and the computer, right? So that part takes a short time. And if you learn how to do that skill, you can replicate it for the rest of the 13 more labs that are coming. And that's how it's ordered like that. But the other one that's really important for you guys to learn how to do in Lab 2 is actually talk to other human beings. Face to face. It's like, imagine that concept, novel concept it may be. Right? It's like, but I can talk to them through internet or everything. That's fine, you do. And we sent an intern to Macy's.com, and one of the biggest feedback that we got from that internship is that they needed better communication and social skills with the supervisor and also the fellow interns, right? So don't discount that. In society, it's very important that you learn how to deal with people. And I told you guys what was the purpose of college, right? A few weeks ago, do you remember? What was the purpose of college? Party? It's to grow up, right? Make your own choices and learn to live in this society that we have. So part of that is you have to learn how to deal with others and interact with others. So these icebreakers and things like that, they do it in all those companies because it's always awkward meeting people. So don't think of this class as just the technical skills, which there will be a lot of that we're going to build up for you over time. But there's also the social aspect. And that's why I want you to help each other out in lab. And that involves actually talking to somebody, right? So if you happen to have a lab with the TA and everything went smoothly, you should have interviewed other people. And so don't take it as a mechanics, even though any assignment or things we do tends to be a little bit superfluous and mechanics of it. But look at the idea behind it. The idea is that you actually learn to make friends. You know, my best friends that I had made friends in my freshman year are still my friends now, like 20 years later or 19 or whatever. So don't miss that opportunity to do that. All right? So in programming, there are things that we call objects, and I want you to start thinking in terms of objects and what it means to have stuff to do it. And this is something that you're really used to typing. Have you remember how to type system? How many times you type system? You know what a system is? Or you see this in code right here, right? That we do to print out something that we want to print out. So it's system, and there's a little bit of a period in there. And for you guys, it shouldn't be so foreign anymore. Although maybe some of you don't actually go to websites anymore. Some of you do, right? Some of you actually type in the address to the website, yes? Or you just search? I don't know. See, society making people a little too lazy. But in general, you have catcourses.ucmerced.edu, right? So that dot is the separator, or what we will call a member or accessing function. Same thing here. We usually say system, and then we say out, and then the print line versus print. And that's what you've been doing for 2 weeks already. So what that means is that there's an overall system. Just like a building, there's some system. And I'm interested in the out portion of it. And in terms of the hierarchy of objects or how I would relate them, I would show it like this, system, and then I want to access out. So how do I separate between the two words without some other weird word saying system out? I have to delimit it or separate it using this dot. Okay? And we do it on the web. We do it everywhere. So usually in your essays that you write, it's a space, right? White space. But in computer science and techie world, we tend to use dots to do that. Okay? So system dot out. And what are the two possibilities that I can access from the out? Print and print line that I'm showing you. So right there, right? So that's how I would structure it. So if system has out, what else do you think system must have that's complementary to out? In, right? That's obvious, right? So imagine having a smartphone. Most of you have smartphones or computers, right? Imagine it just prints out stuff to you and then you can't tell it to do anything. When you touch your thing, it's just like dead. Is it interesting? No, right? So it's always the in and out interplay with some computing inside. That's what gives us our systems. So it's in. And I would now put it both under system, and they both live under system in. Or, sorry, system, and then one is out, the other one is in. I'm going in and out. Is that what? It's just karma. It's just the way it is. So I hope you can hear me. I am really going in and out. This Bluetooth or what? Maybe it's interfering. Oh well. We'll do with what we have. So, I know you all know what selfies are. Do you know what scanners are? Yeah, right? So that's what we're going to actually use. I'm going to switch this. See if I can lessen the interference. To bring something in, I'm going to scan, just like copiers or things like that. I'm going to use scanning to do that. So I'm actually going to utilize a scanner object to do it. And you're actually not going to be introduced to what the object mean and what it all, the relationships until 21 next semester. But we're still going to use it, but sort of just more copy and paste, right? So just here, this line is something that you're going to want to learn how to do which is that I'm going to create a scanner called input. And the name I give it is like, what is it going to be scanning? Some input. From where? System in versus system out, right? So I'm not going to be scanning from an output. I'm going to be scanning from an input. Once you have that, you're going to have this object called input that we can refer to. And then we can now ask it to give us different things that we talked about 2 weeks ago, different data types, you remember, right? An integer, which is all the natural numbers or whole numbers, positive and negative, that's what makes integers. Floating points, which we would call in our everyday usage decimal, right? 1.2, something with a fraction or something with a decimal point. But the thing that it's also going to do is going to give us strings, right? That was the data type that we talked about before, strings. What are those? Well, that's everything you see on the screen. That's everything is a string. Words, sentences, things that has letters and alphabets and characters to them, those are all strings. And I very much would want to read stuff that is strings instead of just numbers. So this scanning concept just gives us ability to do that. And we're going to learn now, start to use those objects more and more. And this is just a reminder from 2 weeks ago what it means to have a Boolean, right? Which is just 0 and 1, true and false. But that only requires 1 bit to do that. It's short. It's like a really small number. And what does that allow me to do? It allows me to encode something between 32,000 plus or minus of it. A character is similar. It allows me to specify what kind of characters or the letters or alphanumeric numbers or punctuations and all these different things, right? Even a white space is a character. I'm going to be able to represent that using character types. Integers, of course, are 32 bits, so they go to 2 billion, plus or minus 2 billion. But that's not sufficient to represent all numbers. I have something called a floating point, which is scientific notation for what we would call decimal numbers. But if I wanted to create something really, really big or something really, really tiny with a lot of precisions, then I would use something called double, which is more precision and better range. So why is it called double? Because it's a double of a float. It takes 64 bits versus 32 bits. Okay? And you're going to be, from now on, start to create these kind of data types in your programs and deal with them and manipulate them a little more starting this week. And finally, the last thing is the string, which is just any sequence of any numbers. And remember, all the integers or numbers also count as characters if we want to interpret them that way. And this slide is written in the order of hierarchy or what we would call precedence or types, right? It's basically 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like that. It's ordered. So a string is higher than a double. A double is higher than a float. Integer is higher than a character. And that's going to start to matter when we go on to the next set of slides, talking about what is the data types and what is the relative hierarchy of things and how do I go up or down. Okay? So let me give you an example of what we mean by that. Let's say we have a float. A float could be something like 1.5, correct? Now, if I ask you to make that into an integer, can you make 1.5 into an integer? Yes, but what would be the resulting value if I just interpret that as an integer? 1, right? So I lose that precision of 1.5. And that's why it's a lower order data type than a float, which can represent the full thing, which is 1.5. But if I have to reduce it down to an int, I start to lose some stuff to do it. Okay. Now if we have a bunch of numbers, what are they useful for? Whoa, these slides are going backwards. Hold on. They're useful for doing all the operations that we're used to doing in all our math classes. So everybody know how to add and subtract, right, between numbers. We also know how to multiply and divide. But that's something, there's a fifth operator that's in the middle. That's called the remainder that we really like to use in computer science. And does anyone know, or do you guys have an idea what is the remainder? Yes?
Well, it's like you divide the numbers and whatever number you have left over, sort of. That's like your...
Yeah, whatever is the remainder after a division operation. That's the key here. Okay? It's after a division operation. That's the remainder. For an example, if I ask you, what is 5 divided by 2, what would most of you tell me? What's the answer to 5 divided by 2? You all want to say 2.5, right? But if you look at the long division form, for example, and I was doing it in elementary school, 5 divided by 2, what would be the number I put on top of 5 divided by 2? Just 2, right? So 2 times 2 is 4, so 5 minus 4 is what? 1. That's the remainder. Do you see it? That's the remainder. So you're basically doing long division, and the answer on top, which we call what? Do you remember? The quotient. The quotient is also an integer, and that tells me the answer of this divide. But the remainder is whatever is left over, or i.e. remaining. That's why it's called the remainder, not the reminder. Okay? So that's the remainder. And we'll do labs making you more familiar with it. I know some of you are not quite sure what that all means, but in computer science it's really useful to have both the quotient and the remainder, and we want to use both of them to do that. Alright, so let's go into these boxes and numbers in them. So I have these 3 boxes, right? How would I refer to them? How would you guys refer to them? 1, 2, 3, okay. Integers, okay. What else? What if I wanted to make it point to a specific box? How would I refer to one of them versus the other 2? How would you do it? I just point my laser pointer and go, that one. This one. If somebody's not seeing it clearly, well, how would we do it? So the point is, why do we have names? It's the question, right? Because it's easy to refer to them. Okay, so we have these boxes, and what are we going to do with these boxes? Well, we're going to do operations on them. Which operators are we going to do? Well, the one that I just mentioned, the 5 of them. So one of them is addition. So if I do 1 plus 2, what should be the result? 3. So that's easy, right? No confusion there. All right. But I want to be able to refer to them by name. I say, hey, take num1, add num2 to it, and stick it in num3 box. And that's what we will call variables and variable names. Right? There are 2 things that's important to them, which is there's a name to a box, and then there's also the data type that appears in this box. So for this particular example that I'm showing you, what kind of numbers are these? Integers, right? Okay. Now if I change the operator to say, instead of num1 plus num2, I have num1 minus num2, 1 minus 2, the result will be -1. So you see, I haven't actually changed the boxes. So if I was referring to the boxes by the value inside of them, it's tough here, because if I say num3, it's no longer 3 in it, right? It has -1 in it. So do not associate the value of the name of the box or the variable related to the actual value in it. I could put 1 million here, and it should work the same way. Okay? But here, because now I have boxes and I have operations, I can refer to them, I can do stuff to them, and I can also name them first, second, and this one a little more descriptively, which is result. So if you look at a variable named result, are you going to be like, hey, is it a number, or is it something that is the ending logical conclusion of some operation? What would you think? Or if I named a variable named sum, would you be confused about what that variable is supposed to do? No, right? Whereas if I name a variable like a, then nobody knows what that means. So we're trying to give you a motivation of why we would want to do a sensible name kind of variable boxes. Okay, so you try to choose the names that make sense to not just you, but everybody else who reads the code. Just like if you write an essay or something like that and you want to use your own language that's not comprehensible to anybody else. Same thing with code. It has to be both readable and easy to write. So we try to have these conventions that everybody will understand to do that. Okay? Now, if I take the same boxes and say first minus second, it's the same operation, but now, because second is 0.5, what is the result as it's shown? 0.5. Now, it was integer in the first box, integer in the second box, integer in the result before. Now, what is the data type of the first box? Still an integer, but what about second? What would it be? Is it still an integer? What is it? Float or a double, right? But let's say a float. Now, I took an integer, I subtracted from it a float, and what did I end up with? A float. So you see how the data types in the expression, it tends to be, the result is going to be the higher one of the two. So do you understand what we mean by lower data type versus higher data type here? Right? Just because this 0.5, if I needed to stick into an integer box, I couldn't. Right? So it cannot contain the result, so it has to be appropriate type. Here, we will say it's a floating type to do that. Okay, so we did this exercise already. First can be what? Most of you say integer, but what else could it be? It could also be a short. It could also be a float. It could also be a double, because all of them can codify or represent, technically, saying 1. Okay? Second box can only be either a float or a double. Okay? And then what about the resulting type? The resulting type will either be a float or a double. Does it make sense? Yes?
Since the first type has a 1 in its box, couldn't it also be a Boolean type?
Ah, yes. But then, what would it mean if I tried to subtract something from a Boolean type?
They just either go to 0 or stay at 1, I suppose.
Logically speaking, it's illegal in Java. When we get to higher level courses, it will be legal. But not right now. So Boolean, it's logical. It's true or false. So even though we represented 1 or 0, they interpret it more like a true and false. So you can't do mathematical operations on true and false. For now. Okay, so just make it easier on yourself. Think of it just numbers as numbers and logic as logic. Does it make sense?
Yeah.
Okay. Anything else? Okay, so we're going to go to more concrete code for you guys to do. Okay, so how am I going to create a box, name first, and put a 1 in it? Well, it's very easy. Code like this. I have to first specify what kind of data type it is, and you'll see here, it says int. So there's no confusion. It already tells you it's an integer type. And then what is the name of that box first? And what am I going to initialize or put a number in it? I'm going to assign something to it. Equals 1. So we're going to say equals or assign interchangeably. So don't get confused with a mathematical thing. This is not saying that this is logically equal. It's an action. Okay? That's why it says it's called an executable statement. We're actually doing something. We're not just checking for something in this case. We will do something, and he says, take the right hand side, which is 1, and stick it into that box on the left hand side, which is first. Okay? It will create this picture. So mentally, you should have that in your head. Whenever I write code line like this, it creates a box with the name first, and I'm going to stick some number into it. What about this one? Well, I'm going to create another box called second, and it's going to be of a double type, and then I'm going to stick 0.5 to it, and I have that here. Okay. Then lastly, what do I have? Well, I'm just going to repeat this, but I want to create result, right? I want to create result, and what is the result getting from? Whatever is in first and in second, subtract those two, put it into result, and I just happen to choose the right data type double to do that, and it's going to implement this 3 boxes plus 1 operator and put a result into the third box. Any questions about all the different components of these three statements and how we sequence through them and execute each of those? All right? Now, what if I modify a little bit, I just have int first? Technically, it's called just a declaration with the type and the name of that variable. How would I draw that? Either in your head or on this slide. When I just say int first, how does that appear to you guys? Let's break it down, yeah.
An empty box.
An empty box, does it have a name on it?
Yeah.
First. So an empty box with the name first. Does it make sense to everybody?
Yes.
We all agree? Cool. So that's what we'll draw. Now, since the box already exists, as a secondary step, I can say, hey, put 0 in it. Then how should I change this picture to reflect that assignment statement? Is it too easy? So I have this box that's empty. What did I put in it? 0. So I just put 0 in it, right? Then what if I do this? I say, hey, first, I kind of changed my mind. Put 1 in it. So how should I change this picture? Change the 0 to a 1. Then what happened to the 0?
It's just gone.
Just gone?
Oh no, it's still there.
Is it still there?
No.
It sometimes exists, doesn't exist, maybe it exists together? Like, how does that work in your head?
No, if 1 replaces the 0, it's like the 0 was never there.
I just kick it out.
Yeah.
I say, here, this is my chair. Only one of us can sit in this chair. Right? Because there's only one box and only one number can go into that box at one time. It's just going to kick out 0 as if it never existed. I'm just going to stick 1 in it. Okay? So have that model be clear in your head that it just overrides. Right? It's actually pretty easy because you guys are used to computers and word processing, right? So whenever I deleted something in my essay or whatever, a character, it's just gone, right? Unless you do undo and go, oops. So it's just gone. It just gets overwritten. So every time I write something, it goes in the same spot or the same location. So it always gets overwritten. All right. Secondary, that's the same line of code, right? So what should that create? Second box named second with the number in it already 0.5. So this is just to differentiate and show you that there are different components even in these seemingly simple lines of code, that there's actually multiple steps to it. I can do different things based on whether or not I want to reuse a particular box or do other things with it. Okay? And then lastly, it's the same code that we have before. Now, what is this example? Well, this example, notice I instead of creating first to be int, now I created it first to be a double type box. So if I stuck 0 into it, since it's a double, it's actually going to stick 0.0 into it. What's the difference between 0 versus 0.0 in terms of its mathematical value? Nothing. But in terms of computer science, it's slightly different because they're slightly different data types. But in terms of mathematical operations, it's the same. So now if I stick 1 into it, it will stick 1, but it will change it behind the scenes for you and stick 1.0 in there. Okay? It's a double. That's an example of a up conversion. On this right-hand side, we have 0 and 1. Those are clearly integers or shorts that I'm using, not Boolean. Then, when I stuck it into a double box, it just upgrades automatically. It's like a free upgrade into 1.0. And then the rest works exactly the same way. Okay? As opposed to down conversion. Down conversion is not free because you lose something in the down. Whereas in the up conversion, you usually never lose anything. So same thing here. We have first box, which is 1.0. And then we have second box, which is 0.5. If I want to subtract the 2, what was the answer again? Beeping? What was the answer? 1.0 minus 0.5? 0.5. Now, this code says, hey, take the result of 0.5 and interpret that as an integer, or alternative way of thinking about it is give me the integer portion of 0.5. So what is the integer portion, or interpreting that as an integer? What would I get? Why does some of you say 1? Because you're hoping that's how we grade, right? You're like, oh, well, I'm so close. What's 85%? It's like A. No. So rounding is what we used to do in math classes. But here, that's why I specifically said here, 0.5, what is the integer portion of it? Right? So we have to take the 0 part. So no freebies, upgrades here. So it will be 0. Does that make sense? No. Okay? So we have now different data types, and we're manipulating them, moving them between up and down. So the down, you have to, what we call explicitly typecast it. You have to tell it, I want to interpret that as an integer. Okay? Now, the next kind of code, our favorite print line. I'm going to use print line to do what? I'm going to print out the result of what I print out. And you all remember what this expression ended up in the result, right? So if I print out system.out.println, what will be my output at the console? Just 0, right? It's not very exciting. 0. So how should I make it a little prettier? Well, I should tell you what that is that I'm putting on the screen, right? So imagine using your smartphone or something like that, and then you open up an app and it says 0. You're like, what is this? It's like, 0. Not very exciting. Right. So this example, I'm going to now take system.out.println and say result is. I'm going to tell you what this is. This is a result of the operation that I'm doing, and then I'm going to print out that result. Now, how does this output appear based on your lab experience? How many lines would I see this output on? Why 2? Because it's print lines, right? I said print it, go to the end, and then go to the next line, and then the result is going to print out on the next line after that. So it's going to look like this. Result is, and then you're like, 0. Is that a good output? I'm asking you, aesthetically, if you go to a shop and like you're picking between different programs or something, you're like, that's a very pretty shirt. It's like, is this a very pretty output? Why? So how would I fix this so that it's prettier? The first print line, I now turn it into a print. And then the result will be prettier. Great. So this will be the first problem on your midterm when we get to it. I'm going to ask you to manipulate these print and print lines and see and make me print out pretty things. Okay? So understand the difference between print and print line, which we've been doing for a couple of weeks. Yeah?
You can also use a plus sign in the system arc.
Oh, are you reading my mind? Or are you cheating, looking at the slides? No. So, remember what we said first lecture, we're kind of lazy and we don't want to do too much extra work. So, there must be a way of manipulating my strings. Remember, a string is a data type also, right? So if I can add 2 integers, what else should I be able to do to strings? Just add them, right? So, there it is. What? What's going on? So what is this going to print out? Result is result. Like, thanks. I knew that, right? Like, you should answer all the interview questions like that. They're like, what is the result? It's like, result is result. It's like, they can't tell you it's wrong. It's a tautology. It's always true, right? It's also called circular logic and good way to get fired. So don't do that. So how should we fix this? So, most of you recognizing that whenever I put stuff into literal quotes, air quotes or otherwise, right, code-wise, it's just going to print that out, right? So you want to take those air quotes out and then put in what? Nothing. Right. Yes?
And if you're missing a colon.
Am I? Oh, maybe it's just off the screen. Imagine it in your head. I see. Wow, you guys are like Eclipse. You're like good compilers. Yeah.
I would just save like 2 extra characters by just saying print, not print lines.
Oh, I see. You could, but if there's code following it, it will screw it up, right? So, good point, good point. I never thought of these issues. Man, you guys are nitpicking. Good thing you're not grading your exams. So, we take those double quotes out, and you think it's funny, but by the time midterm comes, we're actually going to nitpick whether or not you have a space in your print statement. And then you'll be like, but it's a space. It's like, but you're speaking like a gnome. You're like, hello world, like no spaces. You're like, but it works. It's like, no, it's -1, So be careful there. We will do that. So without the double quotes, we have result is what? 0, right? So it's still pretty, yet at the same time it's succinct, and we got it all done in one shot. Great. Actually, so the other way of doing that is that strings can also be variables. Just like any box, we can create a string box and put in a literal quote in it. And how will we do that? Like this. Here's a data type that I want, just like int and double. I'm going to create string on that. What is the name of that box? Out message. And what result, or what's the string that I'm putting into that box? Result is. Then, whenever I print out this print line, I take whatever that thing says and then tag on my results. Notice this space over here is very crucial, right? Otherwise, it's going to say result is 0 without space. And that's still ugly. So here, I'm doing addition on my variable of string type. Right? And then the output is going to be a string. And that's in turn what I print out. And it's going to print out the same thing. Result is 0. I'm just showing you other options on how to do that. Okay? Similarly, I can also take this out message, take result is, add result to it, and print out message after. After I've already manipulated and combined into out message the whole thing that I want to print out, result is 0, and then print out that variable. Right? So if we have boxes and different things we can put into it, as long as we can refer to them later and use them to either read or write stuff into it, then I can start to make a little more interesting stuff with it. So once again, it's going to print out very exciting result at 0. So these are all examples of what we mean by type conversions. The implicit or the free ones. Right? If I have an integer, I can put it into a double. I can also put it into an int, and assuming it's interpreted as a float. I can take 4.0, which may be a float, but I can put it into a double. All of those come for free. All these characters, I can also interpret them as numbers. And then they all go into my integer, floating, or doubles into it. Right? But if I have an integer, if I want to change it to a character, which is a that I define here, I have to downcast it. I have to specifically say, I want to interpret this as a character. Same thing if I had a float, I have to say I want to interpret this as a character. Okay? Same thing for double. What about if I have a float, some number like 0.5 that we've been using? If I want to just get the integer portion of it, I have to downcast it or explicitly tell it, I only want the integer portion or treat this as an integer. Right? Same thing for if I have a double, EE, then if I want to bring it down to either an int or a float, I have to explicitly cast it down. Any questions about this up and down? You'll get more practice over the semester, but just an idea of there's a hierarchy of types, and I can go up or down. So up is free, but down is not. I have to explicitly tell it how I'm going to interpret it. And that's going to be another part of your first problem on the midterm, where we have a random print statement with different types, and we say, hey, what does this print out? And you have to decide, does it print out as an integer? Does it print out as a character? Does it print out as a float? Depending on how it's written. So just understand in this class that we try to teach you both reading and writing comprehension. So you have to be able to interpret what's there, but you also have to produce things based on the description that we tell you to produce. So when you do the lab, keep that in mind. And just don't rush to the end, just trying to leave lab early, right? It may be a little bit of a detriment to you later on. Okay, so we have addition, adding. Adding seems so easy, but it's actually not so simple and easy anymore. If I take two numbers, which both of them are shorts, if I add them up, it will result into an int. If I have a short and an int, that's a little easier to understand because the higher one is the int in this expression, so whatever is higher wins out and it becomes an int. Okay? What about character and character? Character and character are actually represented as number inside of it. So if I add those two up, it will result into int. So most everything is now seeming to be resulting to an int. What about int versus int? If I add those two, well, the answer is just int. That's easy. What about int and a float? Now, for the first time, a float is higher than an int, so I'm going to get a float from it. If I have a string and a boolean, it results in a string. If I have a string in any expression, it will result in a string because a string is the highest, right? We showed it. It was the highest data type. What about a string plus character plus character? We did this in math before, right? If I have 1 plus 2 plus 3 plus 4, how do you evaluate that expression? So the convention that we're going to use is I'm going to go from left to right. So I'm going to take the first operator, which is this plus, do string plus character, which results in a string, and then I do the second plus, which is another string plus character, and it results in a string. Right? Versus if I were to do this character plus character first. If I did character plus character first, what would be the resulting value based on the above expression? An int. So it's a very different output. Okay, so be careful. I'm going to go from left to right. And this is what I'll be showing here. A character plus character, that comes first. So that will be interpreted as a string, int. And then that int will be turned into a string. And the output will be very different. Here, I will print out A and C. Here, it will be an integer that is a combination of A plus C. And you'll see the differences in lab when we get to it. So in general, other than these ones where it's a short and short result in an int, and a character result in an int, in general, whatever the highest data type in the expression, it wins out, and that's the resulting data type that I have overall when I have my result. Okay? So here's a little song I like to sing called May, 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 May. So, do they all seem the same to you? Why not? It's a very weird way of writing main, right? In Java, unfortunately, every single one of them is considered a different word. That's another way of saying I'm very sensitive. To what? To cases. Not in general. To cases. So a capitalized A versus a small a, I consider them two different characters. So the combination of those are very sensitive, and you got to use it in the correct way. And we will encourage you to maintain this naming convention that we're going to talk about. Every naming thing that you begin with should begin with a letter, i.e. it should not begin with the 1 or 2 any digits. Or alternatively, it can start with an underscore. And you're like, why do I need an underscore? That will make more sense later on when we have internal variables that we have to keep track of. It tells you internal versus external. So regardless, it should start with a letter. If it's a class name, just like your first program, second program, third program that you guys are working on, it should be capitalized because it's the name of something, some object, right? First program, averages. It should be capitalized, just like all our names, it's capitalized. If it's some variable name that I use inside my program, you'll notice in all the code that you've seen so far, main is all lowercase. Okay? And you should follow that convention. Everything and all the examples I've shown you in class today, first was all lowercase, second lowercase, result lowercase, num1 lowercase, num2 lowercase, num3 lowercase. Notice 1, 2, 3 didn't appear in the beginning, it appeared at the end. Right? So it just cannot start with it, but it can certainly contains letters, just not starting with it. But if you're going to have multiple words that you want to combine into a variable name that I want to use in conjunction for something, to make it easier to read, because I don't have the advantage of either having a dot or a space to separate out words for me, I'm going to use capitalization for it. Okay? So it still very much start with a smaller case. The first word is always lowercase. But the second word, if I have it, is going to be capitalized. So this one is obviously 2 upper. This one is 2 uppercase. This one is the square. Do you understand the naming convention? Okay? And we'll give you code and examples of using those, and you'll learn this a little more. But it's just a convention. It's a way of having it so that it makes sense to everybody, and a way of writing so that everybody is consistent with it. All right. So how are we going to use all of these? Well, Lab 3. What is Lab 3 going to be about? What was Lab 2 about again, for those of you who did it? Interviewing people, right? But then we're like, why don't we just write a program that interviews people for us? And that's what we're going to do. But unfortunately, when people answer questions and stuff, we have to remember. So how are we going to remember people's answers, do you think? Put it into our boxes, right? We create stuff and then put it in little boxes. But how are we going to make somebody input or type in their answer? How are we going to get it in our program? Scanner. Yeah, everything we've been talking about. So we're going to put it all together in Lab 3. How? I say, hey, system.out.print, what is your name? Right? Then what are you going to answer? Well, I might answer, well, my name is Kelvin, or just Kelvin. And then, what kind of input is that if I have Kelvin? It's a string, right? And how should I get it from my scanner? It's input.next. I haven't shown you how to create the scanner in this slides for simplicity, but in lab code you will see how to create that scanner. So assume that we already have that line of code from our second slide where we have scanner created and it's called input. So now I'm just using it and say, input, give me the next word. And it gives me the next word, which is the name of that person that they entered. And it's going to look something like that. What is your name? And I type in Kelvin. Boom. My name now becomes Kelvin. Right? Now, why did I use print instead of print line for this prompt that we call asking a user to do something? Yeah, it's right there. It's not ugly like over here. Like, what is your name? You're entering the answer right here, right? It's not that pretty. All right. And then the next thing I'm going to ask is, where do you live? And I want to make it customized. How do I make it customized and make Siri or other things make smarter? I just use a variable. Notice that? I get the user's answer, and then in my next question, I've embedded a variable. So no matter what they type in that variable, you're going to call them by that name. So somebody's like, what is your name? Ha ha ha, it's dumb. And like, hey, ha ha ha, it's dumb. Where do you live? So be careful what you type in, right? So since I said it's Kelvin, I say, where do you live, Kelvin? It says Merced. Okay, so I take that city name, and then I'm going to now use the 2 variables I created, which is one is the name, the other is the city. And I'm going to summarize my interview for whoever is reading this program. At the end, it says, hey, the person I interview is Kelvin, and he lives in Merced. Okay, so whatever the questions and things that you guys came up with last week, and even if you do it this week, at the beginning of the lab, there should be enough time. You're going to ask each other, figure out what kind of things you're interested in. It's all the same thing. It's not that hard. But you're just going to learn to now put it into code, put it into practice, so that it's a generalized program that seemingly has intelligence, and it's going to ask you, hey, what is your name? Kelvin. Where do you live? Merced. And then the main thing for you guys in Lab 3 is make sure that you summarize at the very end, right? You don't want to say, what is your name? Their name is Kelvin. Where do they live? They live in Merced, like as you're entering questions. So you should save them all into variables and only summarize at the very end to do that for Lab 3. All right, so I'll see you next week.